compared with other technologies related to communication also. So basically, when we talk about communication, there is always some transmitting end and one receiving end. In between them, communication happens, and these two transmitters and receivers are connected through some channel or media. The media for communication, or we can say the type of transmission media, is divided into basically two types: guided media. Guided media is wired kind of media, and another one is unguided media, which is called wireless medium also. So basically, guided medium is categorized into three types. One is twisted wire pair cables, which we are using from the beginning. Thereafter, with the advancement in technology, coaxial cables came, and these were also having some drawbacks. So we further move on to optical fiber cables that are much more beneficial for us in terms of which act as a better medium for of communication between transmitter and receiver. So if we compare these particular three medias, twisted pair cables, coaxial cables, and optical fiber cables, so certain specifications or certain parameters we will consider. First parameter is speed. Speed. The highest speed is supported by fiber optic cable. That is range for this particular fiber optic cable is, it lies in the range of 10, 100 or 1000 Mbps, and in Gbps also it can support 10 Gbps, 40 up to 200 Gbps. While if we talk about UTP cable, UTP cable is basically unshielded twisted pair cable. It supports up to 10 Gbps only. Coaxial cables can, maximum speed for coaxial cable is about 1000 Mbps only. So in terms of speed, fiber optic cable is better. And if we talk about bandwidth, then bandwidth for this fiber optic cable is about 4700 megahertz. Similar bandwidth is used for UTP cable also, but less bandwidth of about 750 megahertz is supported by coaxial cables only. And the distance between transmitter and receiver, that can be supported uh, without with less distortion, without any major problems. That distance supported by fiber optic cable is maximum, which is about 80 kilometer, while only less 100-meter distance is supported through UTP cable, and better distance in terms of as compared to UTP cable, coaxial cable can support up to 500-meter distance. So in terms of distance, fiber optic cable is better one. And in terms of price also, the lesser price we have for fiber optic cable, while UTP and coaxial cables are costly. And security is basically here also, security is high for fiber optic cable, while it is low for other two medias. And if we talk about interference, then interference, although it affects fiber optic cables also, but we can compensate with that. But UTP cables have show very poor interference rating, because lot of interference is there, like electromagnetic interference, etc. While coaxial cables are better as compared to UTP cable. Fiber optic cables do not have, they can reduce EMI. There no EMI is present in optic cable, and many more advantages are there with fiber optic cable. So if we compare all the guided media or wired media, then we can say the optical fiber cables are better as compared to twisted pair cables and coaxial cables. Now, one minute. Now, these are wired kind of twisted wire pair cables, and this one is black one is this fiber optic cable. Now we will move on to another type of transmission media, which is wireless. And within wireless, it is also divided into three types. Radio waves. There are radio waves based on, these are basically categorized in terms of frequency ranges, and microwaves are also there. And third one is infrared range. So basically these are the modes of wireless medium. If we talk about microwave, so these are basically electromagnetic radiations whose wavelength ranges from 1 meter to 1 millimeter, so also known as millimeter wave, and their frequency lies between 300 megahertz to 300 gigahertz. Basically, the applications of these microwaves are WLANs, wireless local area networks, cellular phones. These are used in cellular phones also, that are mobile, deals with mobile communication, and satellite networks. So, microwave wireless medium can support WLAN, cellular phone, and satellite network, etc. Now, infrared signals are those particular signals which have frequency in between 300 gigahertz to 400 terahertz frequencies, and their wavelength lies in the range of 1 millimeter to 770 nanometer. And basically infrared range, this media is used for short range communication, and here very high frequencies are supported. These have some certain specific characteristics, like these cannot penetrate walls, and it can be used to transmit digital data with very high data rate. Where infrared is basically used for short range communication, and terahertz frequencies they can support. Now, radio waves, we are using these radio waves from the beginning when communication basically started this technology. Then these are basically electromagnetic waves whose frequencies lie in between 3 kilohertz to 1 gigahertz. This is the normal radio wave frequency range, and these waves propagate in a sky mode. These can travel long distance, so they are used for AM radio broadcasting also. So these are AM radio waves are used. Radio waves are basically used for a long distance kind of communication. Now, this is the picture related to mobile communication. How cellular communication, in very brief picture, that is indicating these hexagonal cells. Each hexagonal cell is having certain base station, and this is the transmitter cells. Also, they are working as a cells transmitter receiver, and means all this geographical area is covered by these hexagonal cells, and these hexagonal cells have certain base station. This is the picture of base station, and in this way, and this was in terms of how the area is covered, how we are using different transmitters, receivers we are putting there in each cell, so that their communication should not break in between in any point. And this is the picture related to the different frequency bands that are allocated to different modes of communication. Now, means communication is used globally, so that every area or every person within any area should have should lie in that particular network. So this is a wide kind of network, global network, that this network communication happens. The major demand for this uh, major demand in case of communication is ultra high data rate. Ultra high data rate is basically, so day by day technologies are getting advanced. So in basically 1980s we were using first generation of mobile voice communication. Here only the analog voice can be. While when we move on to 1990s, then a new technology came into picture, that was related second generation of this mobile communication. Here, digital voice can be transmitted in this particular, with this, using this technology, and efficient voice can reach to the millions of the people. Thereafter, we shift our focus shift on to transmission of mobile data along with this digital voice. Then 3G, uh, third generation for this mobile communication came into picture in 2000. Here the mobile data, we can transmit data through the mobile also. Now in 4G 2010 onwards, we are using broadband. We are transmitting broadband data with our same kind of or advanced kind of mobiles. Clear? So this is, in this way, different generations came, new features get added in new generation for the communication. And like that, if we compare all these generations, first, second, third, fourth, now we are moving on to 5G. So we will compare it in terms of bandwidth, frequency, data rate, basic characteristics, and technologies used for these particular generation. Now, if everyone wants certain bandwidth for communicating, so basically, bandwidth is issue. So technology will be better if lesser bandwidth will be utilized. So as you see here, that first generation was using 150 to 900 megahertz. Second generation, then thereafter it, uh, 900 megahertz was allocated to it, or it can work in this range. And third generation, we have reduced the bandwidth up to 100 megahertz. And also fourth generation is 2010 onwards, and here also the bandwidth is reduced up to, we are using same bandwidth, 100 megahertz. Now, but further we want to use further reduce the bandwidth so that more number of users can be accommodated. Now, frequency, if we talk about, the first generation was using analog kind of signal, because analog voice we were transmitting, and here 30 kilohertz the signal was transmitted with 30 kilohertz frequency. Thereafter, in second generation, digital voice, where digital voice can be transmitted, then frequency utilization was up to 1.8 gigahertz. In third G, it was 1.6 to 2 gigahertz. Further 4G, the frequency range for the signals was 2 to 8 gigahertz. Data rate should always be high for any better technology. So as you move from first generation to fourth generation, you can see that data rate is continuously increasing. Motive of scientists is to increase the data rate and reduce the bandwidth. Then only more number of users can be utilized in better way. More number of users can be accommodated for communication. So only 2 kbps for 1G, thereafter 64 kbps for second generation, 2 mbps, 144 kbps or 2 mbps was supported for 3G, and up to 100 mbps now we are using 1 gbps data rate. We talk about characteristic. So 1G was first wireless communication, and second G was related to digital, and third G was basically related to digital broadband with high speed, and fourth G is deals with high speed, and all IPs can be connected through. Technology, if we first generation, what technology we were using, it was analog cellular, and in second G, its name was digital cellular system, where we were using GSM. And in third generation, we were using the technology CDMA, code division multiple access, and UMTs, or UMTs are universal mobile telecommunications, and edge is nothing but enhanced data rate for GSM evolution. It is also known as GPRS. In fourth generation, we move on to new technology, that was LTE. It was long-term evolution for the GSM. Then thereafter, Wi-Fi, wireless fidelity came into picture. Now we are moving on to World Wide Web. But what is the bottleneck problem here? Last mile problem here. Here we can see that the RF band lies in between 3 kilohertz to to 300 gigahertz of the electromagnetic spectrum. And use of this band is regulated by local and international authorities. So this much RF band is allocated. While if we see for a wide area network where major cities are connected, then wide area network supports very extremely fast speed. These are basically fiber based, and these can support data rate up to terabyte per terabits per second. Clear? And local area networks are used in buildings. These are also fast, but these are not fiber based. Here we have to connect each of them. So this is the bottleneck problem, because connections in between are typically a lot slower from kbps to gbps. So speed limitation is there. How we will connect this wide area network with the local area network? These are the problems, and also we have to work within the allocated electromagnetic spectrum only. This is also the problem. Now, in short, we will compare the radio frequency wireless standards and free space optic. Now, before that, before explaining this particular comparison, I I have to communicate one thing on what is the difference between normal optical communication and free space optic. Basically, in this particular lecture, we will mainly focus on free space optic, but the basic difference between normal previous optical communication and free space optic is fiber, optical fiber communication was using wired media. Here the glass or glass kind of material is used for transmission of optical signals. While in case of free space optics, it can be, there is no guided media. Wireless medium can be used for this free space optics. Here, optical signals, optical beams may be transmitted through 1 minute. Here, optical beams are can be transmitted through air or anyways. Clear? So this is the basic difference. Further, we will cover this topic, free space optic, uh, a little bit in detail. Now, the parameters for comparison of this radio frequency and free space optics are bandwidth regulation. Here, no bandwidth regulation is desired in case of free space optic. Here, approval from is not required for ISM bands. So, what are ISM bands? ISM bands are the portion of radio spectrum reserved internationally for the industrial, scientific, and medical purpose. So we don't have to take permission from this particular band. So this is bandwidth regulation is not required in case of FSO. Wall penetration also does not happen in here. So is more secure as frequency can be used in adjacent rooms, because wall penetration does not happens for FSO. Snow more affects FSO as compared to radio frequency signals, while rain is dangerous to radio frequency and little bit less to free space optic. But both of this, snow and rain, these parameters reduces the range for the communication. Multipath discussions, you know that if wirelessly we will transmit our signal, so they will not transmit in a particular path. They will their path may be any. They may travel through any path, and a number of signals will reach at the receiving end through different paths. So dispersions also happens there. So this is a problematic for if we want to have high data rates. So this dispersion, high dispersion, basically becomes the problem if we want to support high data rate for FSO. Fading is also a problem for radio frequency, but it does not affect our free space optic. So we can simply fading play important role in basically the what amount of signal strength we will receive at the receiver. This fading plays important role. So fading does not affect very much to free space optic. So the design of link is what? Link is the whole path, whole particular communication path between from transmitter, channel and receiver. Here different all the things in link design will be considered, like what should be the receive power, what should be transmitter power, what are the distortions or dispersions that are occurring within the medium, how we can reduce that. So link design is simpler, becomes simpler because this factor do not affect our FSO. Noise. Noise plays important when we talk about communication. Always we have to consider the presence of noise. Then we have to evaluate the performance of our communication technology. The dominant noise plays a dominant role. Here, in case of radio frequency communication, other users are acting as a noise. Clear? So desired person, the signal that is traveling due to desired person is not noise. Other signals of other users are acting as a noise for the desired signal. While in case of free space optic, here the signals travel in the form of light. So here the background light will act as a noise for free space optic. So this is implication is that these are used for short range communication. Path loss is high for both kind of communication, whether it is RF or FSO. Now prime parameters for this, prime parameters are data rates. Very high data rate, Gbps range is supported by free space optics. Device size also becomes smaller for free space optic in comparison to radio frequency one. And bandwidth, here I have told you here permission is not required. So here free license is there in case of free space optic, but while radio frequency for this communication a permission is required, because their users are affecting others' data. Security, in terms of security, low security is for radio frequency and very high security. If we talk about network architecture, so these are scalable. Scalable means these can be merged with another network architectures also. But here only one type of network cannot be merged with, cannot be used along with another kind of network. Link performance effects are both. Here, fading, rain, interference affect the link performance for radio frequency. Here, the rain do not affect. Here, the fog or mainly atmospheric turbulence, misalignment and obstructions affect the free space optic communication. Channel distance is long in case of radio frequency, but it is very small. It is small for free space optic. Although they are free space optics support high data rate, but in terms of channel distance, this is very small. These are used for short range of communication. Short range communication. Here the I have already told other source and noise was source, background light was source. Attenuation here much more fog attenuation is observed in case of free space optics. Now we are comparing our previous radio frequency communication. क्या हमारे पास what we were having, the GSM we were using, and the market share for major GSM mobile operators as of March 2019 in percentage is given in this area. Here the BSNL was using only 10.51% of this total, and Vodafone Idea was using much more. RAS Geo was given 26.77 mobile operators users, and Bharti Airtel was using approximately 28.38 market share percentage. Now gross revenue, 1 minute. हेलो, हाँ बताइए. हाँ, अभी नहीं आई, अभी नहीं आई है, आज तक नहीं आई है. हाँ, मंडे में लिया था. वो तो अभी सुनिए, अभी जो भेजा था उसमें चेक कर लिया, उसमें तो नहीं था। हरी सर ने जो भेजा था ना, हाँ उसमें नाम नहीं है मेरा। तो देखते हैं, मैं पता कराऊंगी। ठीक है, ठीक ठीक। Now this is the revenues related to different operators. Vodafone was the major revenue collector. Thereafter Reliance Jio, then Bharti Airtel. Now FSO and other technologies. FSO, now one more comparison is there along with satellite also. Here we will compare coaxial cable with satellite, optical fiber and free space optic. Earlier we have compared it uh, the optical fiber media to unshielded twisted pair. So here the coaxial cable is transmission. The transmission speed varies in case of free space optic, while it is fixed for coaxial cable only 500 Mbps, and for satellite 90 Mbps, and optical fiber can support up to 100 Gbps. Ease of installation, if we see, so for coaxial cable and free space optic is moderate, otherwise it is difficult for satellite. Installation process is difficult for satellite as well as optical fiber also. Cost is also high for optical fiber, but it is in the beginning for satellite it is high, but in terms of if we talk about the how for how many years it can operate, it becomes moderate. And the coaxial cable uh, cost and free space optic is also less costly. The maintenance difficulty for coaxial cable is moderate, while it is low for remaining all. The skills required to install are moderate in case of free space optic and coaxial cable, but it is high for satellite and optical fiber. Applications, here, applications you must know, you should learn this. Coaxial cables are used for computer network. Satellites are used for long distance communication. Optical fibers are mainly used for point to point. Satellite are for point to multi point. Free space optics happens between buildings, short range communication. Advantages are Advantage of free space optic is in terms of price and performance. Performance wise, it is better, and price is also low. But here, uh, if we talk about the interference, then less susceptible to interference are coaxial cables. Satellite benefit is key. These are their speed is high. They are available also, and optical fiber are not susceptible to EMI, while twisted wire pairs were having the maximum electromagnetic interference. Disadvantage, disadvantage if we talk for free space optic is the problem of uh, atmospheric turbulence, fog, etc. that deteriorate the performance of free space optic communication. While disadvantages for this particular coaxial cables are different. These are the optical fibers are difficult to terminate. The problem with the satellite is propagation delay. For coaxial cable, these are bulky and difficult to work with. Now, fiber-based transmission test systems, which is already established, and the main benefits of fiber-based transmission systems are these have very high capacity. High capacity means these support very high maximum bandwidth. So these are bandwidth efficient. Next is these are also highly spectral efficiency is also there. Or high transmission reach means longer distance. For longer distance, fiber-based system can be used, and high power, high energy efficiency is also there. Receiver is very sensitive in case of fiber optic transmission system because these are photo detectors and these are much more sensitive. And less complex transmitter and low cost is there for fiber based system. And use of repeaters or optical amplifiers is also reduced in case of fiber based transmission system in comparison to previous communication system that we have studied in analog or digital communication. Lot of number of repeaters were used because these can be fiber-based system can be used for longer distance communication. So less use of repeaters is needed here. Now, different factors for evaluating the fiber optic system design. How we will evaluate the fiber optic system is better one. What are the necessities? So first of all, we will uh, talk about the what type of. It will dependent on the type of fiber. The fiber is of two types: single mode and multi modes. Each one have its drawback and advantage. So it will depend on the type of fiber also, and it is system factor is dependent on operating wavelength also. How operating wavelength supports, because the whole operating range for optical communication is divided into three windows. First window support about 600 to 800 nanometer wavelength range. These are basically divided in terms of wavelength range. The first window also gives a lot of dispersion attenuation, so cannot be efficiently used for communication system. Thereafter, second window is related with 1310 nanometer. Here, the second window offers very less distortion as compared to first window. Attenuation and dispersion distortions are less in case of second window. So this can be used for optical communication. But 1550 nanometer wavelength, this particular wavelength, at this wavelength, the attenuation becomes very less or dispersion becomes very less. So this wavelength range is basically, this particular wavelength is used for high speed communication, and where we have to transmit very high data with very high data rates. Clear? Next is transmitter power. Basically, we express it in dBm, and the transmitter are different types, like the different optical sources we have to use for transmitting. Lasers and LEDs can be used. Lasers and LEDs have their certain features. Lasers are preferred in comparison to LED. Although the LED were used in majority, but in case of optical communication, lasers are preferred. Receiver sensitivity is also expressed in dBm. The sensitive receivers are used. Different kinds of detectors can be used here. The photo detector, that is, it is divided into two or three types. Pin diode we can use as a photodetector, or APD, avalanche photodiode, can be used. Each have its particular characteristic. Based on that, we have to utilize. So the type of photodetector will also affect the performance of the fiber optic system. So it can be, fiber optic system performance can be evaluated in terms of type of fiber, the wavelength used, what type of source we are using, and how much power can be transmitted through it. Similarly, what type of receiver or photodetector we are using, and what is the minimum power that receiver sensitivity, that is, receiver sensitivity is the minimum received power that can be detected by the receiver side. Now, system factors, the another system factors are modulation schemes that we are using. Which scheme we are using for this, it will also affect the fiber optic system design, whether it is AM, FM, BCM, or digital kind of modulation rules. BER, how much BER? BER is related for digital systems only. It is not calculated for analog system. There 10 to the power minus 9 to the 10 to the power minus 12 typical BER is used basically uh, uh, used here. Signal to noise ratio is specified in decibels, and here it system performance is also dependent on the number of connectors, because each of the connector will introduce its certain loss. So less number of connectors should be used, and number of, it is dependent on number of splices also. Splices also increases the number of splices. If we increase, then loss within the fiber will also increase. There are certain environmental requirements also, like humidity, temperature, and exposure to sunlight affect the system performance. And mechanical requirements are where we are using this fiber optic cable. It it will depend on that also. Flammability, like indoor outdoor application, which kind of application we are using the fiber optic system design. Now, for this evaluation of this fiber optic system design, a link budget analysis is to be done. And link budget analysis, in this particular, we calculate power budget, bandwidth, rise time budget, and financial budgets are considered. Then the certain design is considered. Now, this is the whole spectrum for the optical light. You can see, you have studied it many times, this the visible range, where with your, you can see this range of wavelength is visible range 600 nanometer, and below this infrared range, whose range is 800 to 1400. Infrared A, B, C, it is divided into three particular categories. So this infrared means millimeter waves are infrared. And above this visible range, you can see the ultraviolet range for the basically light, and the range wavelength range for this is from 100 nanometer to 400 nanometer. So 100 to 400 was ultraviolet, 400 to 800 was visible, and below this is infrared range. And we have to use what? Infrared range communication. So this is independent of industrial, scientific, and medical bands. Is say it is different, so no license has to be taken for using this particular band, and the band lies in between 700 nanometer to 1700 nanometer. So this optical wireless based transmission system, optical wireless based transmission system means free space optic. It is very secure kind of connection. It requires matching transceiver carefully aligned to complete the transmission, and it is invisible. Narrow optical beams are basically used here, which are difficult to find and intercept by other ones. It is cost effective, ease of deployment is there, low power consumption is there, and these show but this particular system also show immunity to electromagnetic interference. Now, what are the challenges? These were the characteristics of optical wireless based transmission system. Now, there are certain challenges because it is wireless kind of media. So, what kind of challenges are there? In between optical source and optical detector, a lot of factors are affecting it, like cloud, snow, rain, gases, fog, smoke, all are affecting. So, these are the challenges for um, this kind of communication. So first of all, we will see what environmental factors are affecting the free space optical communication. Now you can see that these are the particular parameters here. Due to building motion also, if suppose this one is here, the beam is incident from this particular suppose building, then a movement of this building will also affect. Clouds at high range will affect less are this beam signal, but low range clouds can affect. Certain obstruction may be there in this basically line of sight, and here the windows attenuation are can also be there, and range fog may affect this. So here each of these factors attenuate or reduces the signal, but there are ways by which we can reduce these environmental factors. Next challenge is atmospheric attenuation. Atmospheric attenuation is due to absorption or scattering of optical signal due to airborne particles, also known as scintillation. In previous slide, I have shown it. Scintillation. This one, these circles are indicating scintillation. This is absorption or scattering of optical signal due to airborne particles. And next, atmospheric attenuation may be due to fog, but it may be due to rain, snow, smoke, dust, etc. Fog is due to basically smoke, dust, and um, basically snow, smoke, and dust, etc. Clear? And it can result in this atmospheric attenuation can reduce the strength of the desired signal. Means completely the signal may get lost. So this is the problem. So high availability deployment requires the short leg that can operate in the fog, because long distance communication in such an atmosphere becomes difficult. So in such atmosphere, if we use short range communication, then that is short links. Through short links, these particular optical free space optic system can be deployed. Now these pictures are also related to the atmospheric turbulence, how they are affecting, like low clouds, rain, snow, and dust. These pictures are indicating how they are affecting our desired signal. Low clouds are similar to fog. They accompany rain and snow. And rain, basically, due to rain, the link becomes down. And water sheeting on windows also affect the system. Heavy snow can cause ice buildup on windows, and it may bring whiteout condition. What is whiteout condition? It is a condition of diffused light when no shadows are cast due to continuous white cloud layer appearing to merge with white snow surface. No surface irregularities of the snow are visible, but whole portion may appear like a dark object, so there is no visibility in the horizon. Now scintillation in detail. This process is scintillation. Like here, the beam is spreading or wandering due to propagation through air packets of the varying temperature, density, and index of refraction happens. This affects our narrow beam signals, and it result in increased error rate but not complete outage. Means completely the signal did not get lost. The certain signal strength is received at the receiving end. Next challenge is building motion. Building motion is like this, uh, due to vibrations, due to wind. The magnitude for sway or wind is medium, while vibrations, the magnitude of vibrations is low. So this also affects our free space optic system. Next one is compensating for building motion. There are basically two methods for compensating for building motion. First one is automatic pointing and tracking. What is it? It allows the narrow divergence beam for greater link margin. And here the it will, if we have this kind of system we will have here, then the additional cost or complexity of the system will also increase. Here we can see that 0.2 to 1 meter beam, narrow beam width is used, which can travel up to distance 1 kilometer. And second one is large divergence and field of view. Here the beam spread is larger than the expected building motion. It reduces the link margin due to reduced energy density, and the cost becomes also low. Here the beam width is larger, like because divergence is larger, 2 to 10 meter spread, but the distance is same. Next challenges. There were main four challenges which were affecting the free space optic communication. First one was fog, then absorption, scintillation, and scattering. How fog is affecting? It modifies the light characteristics and hinders the passage of light. And scintillation, how it is affecting? It causes fluctuation in signal amplitude and leading to image distortion. And how absorption affect? It causes a decrease in the power density of the signal. And scattering, basically, it reduces the beam intensity significantly. These are the many more applications are for optical wireless communication, that we can use optical wire, wireless communication where the geographical area is unsupported. These are used as last mile access, means point to point network we can have for this, where quick disaster recovery are needed. Even NASA is using to this optical wireless communication to communicate with its spacecraft. Now, deployment of FSO, free space optic. Yes, deployment behind the windows. Basically, here the we can do rapid installation without wrenching and permitting. Here we can provide the direct connection to end users, and no rope rights or no riser rights are required here. These owners. Basically, it is cable free. This picture is indicating cable free FSO, free space optic, in London Olympics 2012. Free space optic was used in this Olympic 2012. The system is deployed. Benefit of this system is 1 minute. हेलो. हाँ 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 मैं अभी करती हूँ. ठीक है, कुछ इम्पोर्टेंट हो तो बता दो, नहीं तो मैं कर लूंगी अभी. ठीक है, ओके ओके. Yes, this system is deployed within an hour with 70-meter range, and it can achieve 1 Gbps data rate transmission speed. Now, basic thing, how free space optic works. So first is basically, yes, first step is here the network traffic can be converted into pulses of invisible light that will represent ones and zeros. Suppose this is transmitter and this one is receiver. And first of all, the complete network traffic will be converted into pulses representing 1 and 0 in the form of invisible light. Now, second is transmitter projects the carefully aiming at light pulses into air. So it projects the carefully aimed light pulses into the air. Third is receiver at the other end of the link collects the light using lenses or mirrors. So with the help of lenses, receiver have to collect this particular light. Fourth is received signal strength will be converted back into fiber or copper and connected to the network. So here the reverse means it is full duplex kind of communication. The transmitter may work as a receiver and receiver may work as a transmitter. Full duplex mode communication may happen here. So anything can be done. Many number of things are possible with this FSO. Here very narrow and directional beams are required. Beams only a few meters in diameter at a kilometer range. They allow very close spacing of the links without interference. No side lobes should be there. Such narrow beams should be used, and these are highly secure. And here, with the help of narrow beams, we can efficiently use their energy. And ranges of 20 meter to more than 8 kilometer is possible for by using these narrow and directional beams. So for free space, optic communication requires very narrow and directional beams. Clear? Now, channel, what kind of FSO channel is? Different channel, you have seen that channel is always modeled mathematically based on the atmospheric condition. So for low turbulence a certain channel can be used. Moderate turbulence, another kind of channels can be used. For high turbulence, uh, another modeling of the channel can be used. So different modeling like log normal, negative exponential, and gamma gamma, these kinds of modeling can be used as a FSO channel, indicating depending on the different kind of turbulence introduced by the atmosphere. Now, performance parameters. Yes, performance parameters. This is the complete right side. This block diagram is indicating the complete free space optic, the block diagram for FSO. First, the source is required, thereafter modulator, then a driver circuitry for optical source. Laser diode will be used, which is acting as a transmitter also. Then this signal will be transmitted. It may be, in case of FSO, it will be transmitted wirelessly in the form of narrow light beams. Thereafter, a receiver photodetector is required, which will convert this optical power into electrical power. Or if here amplifiers will be needed, because at the receiving end the strength of the received signal is very small, so we have to amplify it. Certain signal processing equipment can be used here. Demodulator in transmitter part, whatever kind of modulation technique we have used, depending on that we have to use the demodulation technique at the demodulator side also, that finally the desired signal in desired form will reach to the destination. Now, the how we will indicate that this particular type of communication is better. What parameters we will calculate for this system that are indicated here. First is bit error rate. Bit error rate. It is indicating the number of bits that are having error in ratio to the total number of bits transmitted. The bit error rate should always be low, and FSO indicates low bit error rate. It should be low. Clear? These are energy efficient. Energy efficiency should be high for this particular communication. Signal to noise ratio should always be high. You know that it is the ratio of signal power to noise power, and noise should always less affect desired signal. So noise power should be low and signal power should be very high. And these must be spectrally efficient also. For high long range distance, this should be used. So we always consider that distance of communication should be increased. Outage probability should decrease. Here the receiver, what is outage probability? Received SNR is less than the threshold SNR. So it should be always low, and capacity of the system should always high. Capacity is indicating the bandwidth or the number of users that can be supported by the system. Now, research possibilities. The basically we have for FSO we have to work on the turbulence mitigation techniques. Basically, it is divided into two types depending on the wireless different network layers in which it is operating. So physical layer methods may be there, and TCP other layers methods may be there. It is divided into two types. Both, while working on these, all these will affect the performance of the free space optic. Like here, we have to calculate different parameters in case of physical layer method: aperture averaging, diversity, transmission, modulation. Mainly the modulation schemes works for this. Coding, through coding we can improve it. Isolation, jitter should be less. We have to reject it. Background noise rejection should be there. And even we can have hybrid RF with FSO link. 1 minute. हेलो. हाँ. नहीं. बताओ. अब मैं बाद में बात करती हूँ. ठीक है. ठीक. Hybrid, even FSO can be connected with hybrid links, then it will be better system. Like similarly, if we work on another model, that is transmission control protocol layer, it is related to this particular layer. Here retransmission, reconfiguration, rerouting, quality of service, and this replay are desired. In this, research may be done in this particular layer or in this one. Now, free space optical communication has many significant advantages, such as large transmission capacity, very high transmission rate, and good immunity to electromagnetic interference. The PER performance of these systems, FSO system, is highly susceptible to adverse atmospheric conditions. Atmospheric condition we have done in detail, like temperature and pressure variations that are responsible for refractive index variation of the air and which causes atmospheric turbulence. Next is atmospheric. This atmospheric turbulence lead to severe degradation of the signal optical intensity at the receiver. So it increases the BER, that should be low for better system, and it can even break the communication link. Link may not establish if lot of atmospheric turbulence is present. To overcome the challenges of the atmospheric turbulence, the main factor is that we can implement for high performance FSO system is advancement of modulation technique. When much work is needed in this area, which can be done. Next is under the premise of high transmission rate and low PER, by choosing one appropriate modulation technique and corresponding demodulation technology will reduce the effect of atmospheric turbulence on the FSO communication. Now, modulation schemes for FSO system. There are three important matrix measures that need to be considered. One is power efficiency. Power efficiency, due to skin and eye safety, the emitted optical power is limited. Therefore, these modulation schemes that are having high peak and low average power would be the suitable option for FSO system. Clear? So high peak and low average power is desired in case of FSO for safety of skin and eye, because these are optical waves. Next is bandwidth efficiency. This is maybe more important for non-FSO system, but in case of FSO system, optical carrier have unlimited bandwidth. Clear? Next is simplicity. Simplicity of the modulation implementation is very important because it increases the cost of the total system. So the modulation scheme should be designed in such a way that it should be simple, it should be bandwidth efficient, and it should be power efficient. So these three parameters we have to consider when we do work on modulation schemes for FSO system. So these are the advanced modulation like PPM, BPSK are used. These are very advanced modulation techniques for FSO system. Number of this chart is indicating how it is affecting, how on increasing SNR, BER is reducing. This is indicating no turbulence, because at this much only SNR we have reduced the BER, but for these at very high SNR levels are desired to reduce the BER to the value 10 to the power minus 6. Clear? So PPM pulse position modulation, how it is better? Here the noise interference is less or minimum due to constant amplitude, and it shows high power efficiency among PWM, that is pulse width modulation and PAM. BPSK can also be used here. In this particular technique scheme, information is first pre-modulated using BPSK technique, then before being multiplexed in frequency domain prior to intensity modulation of the light source. So this from this particular reference we have taken this diagram. Now what is the market growth for the FSO system? The market growth for FSO system is here. The global free space optic market size and forecast. It is for the years 2015 to predicted up to 2024. How it will grow. In 2000, you can see the slope of this curve. How it is increasing year by year. In 2024, approximately this much million people will use this particular technology. And this is here we have compare the fiber system with the LOS, other millimeter waves and FSO system. So you can see there how the market growth is affecting for each of the technology. Now these are the references that I have used for making PPTs. Now if you have any questions, you may ask.